Alright guys, today we are talking about geometric probability. This is the last section from chapter 10, which means that a chapter 10 test is likely approaching. But this is a cool section that kind of ties in the rest of the chapter in a new way that involves a little bit of logic as well. So let's get right into it. Alright, so first of all, before we get into the geometry, we need to talk about what probability is, right? We need to talk about what it is. So, the concept is this. We want to look at probability as looking at comparing your possibility for success versus your total possibilities, right? So, it's a ratio of the possible successes, meaning things that you're wanting to happen, right, over all possibilities. So for example, if you're dealing with like a coin, right, and you're saying heads or tails, well, if you want heads, then you would have one chance of success, right? So, and if you want, but how, okay, let me rephrase that. If you're calling heads, there's one possibility for you to succeed, and that's the coin landing on heads. But how many possibilities are there in total? Well, there would be two possibilities, heads or tails, which means you'd have 1 out of 2, or 50% probability, right? Just dividing 1 divided by 2 gives you 0.5, which is 50%, right? Which, again, we're not going to go over that, but that's the concept. Now, typically leaving it in fraction form like so is just fine. You don't need to change it to a percentage, you can just leave it as a ratio. So, just FYI. There's also a concept where if I'm looking at the probability of success, let's say the notation would be something like this. If you have the probability of success, that's what that P means. This means probability of success. So I'm going to use this notation a lot to stand for probability of something happening. So probability of success is just 1 minus the probability of failure. Meaning, if I have a 25% chance of succeeding, well then I would have a 75% chance of failing, right? And 1 minus 75% is 25%. So that's kind of just a relationship between these things. And again, we use this number 1 here because 1 means 100% chance, right? All of your possibilities add up to 100%. So success equals 100% minus the percent of failure, or vice versa. Failing is 100% minus the percent that you succeed, right? So that's kind of just a general overview of probability. Now, how does that relate to geometry? Well, let's look at an example. We have a spinner like this in class, right, where you have at the center here, there's a little arrow, and you're going to spin it around to decide, something, whether music is being played or who goes where's for dinner or whatever, right? But in this case, I can ask you, what's the probability of landing on red, as is shown in the picture? And again, we're going to assume that each of these is 90 degrees, okay? And that this is the center, so we'll call that C. So the probability of landing on red, well, again, it's all of the possible successes. A common mistake is just to say, oh, well, there's 4 colors, so it's 1 out of 4. Well, that's not necessarily true, because you could have something like this, right? You could have a circle like this, where you have 4 colors, one, two, three, four, yeah, 4 colors, but clearly this one has more of a chance of success than this one, because the areas are different, right? So we can't just say that this section 1 and this section 2 have the same probability, because they're different sizes, right? So you're really comparing the area of the red over the total area. Right? Because the only possible spots is that it lands on this circle, right? And how do we identify this circle? Well, we identify the area of this circle. So in this case, we would say the area, and we're not going to go into too much detail on this problem because it is 90 degrees here, right? Which means, and it's from the center. So from the last section, it's going to be 1/4. Here, I'll show a little bit of detail. 90 over 360 pi r squared, right? This is from the last section. 1/4 of the area using this central angle here again, right? Over the total area, pi r squared, which would simplify, because this cancels and these cancel, right? Which would simplify to just 1/4. Okay? But again, in this case, it's not because there's 4 colors, it's because it's 1/4 of the area. Okay? So that's kind of a basic, concept of how we're doing this. Let's look at a different example. It's a little different. So in this case, I'm asking for this is example 2, I'm asking for the probability of landing in a box. Probability in landing in any of these boxes. There's 4 boxes. I can't count, obviously. 1, 2, 3, 4. There's 4 boxes. And I'm asking the probability of landing in any of them. And if you want to relate this to real life, you could think of a carnival game where you're trying to throw, a ping pong ball into the little things floating on the water. Like, imagine these are the things floating on the water, okay? So what we do here is we first need to find the total area, right? So we're going to go with that first. We want to find the total area. And that's looking at the shape or the area of this entire shape here, which is a circle, right? So we need to find the area of the circle. So the area, I'm going to put a tot, is pi r squared, because it's a circle. And what's the radius? Well, we know that the diameter is 36. Ooh. Pardon me. Oh, excuse me. Sorry, guys. We know the diameter is 36, which means that the radius must be 18, right? The radius is 18. So if we're looking at the total area, we would get pi times 18 squared, right? Pi times 18 squared. And again, I'm going to leave it exact because I don't care about the decimal. So when you are squaring 18, right, you're going to get, I don't even know, I don't remember that off the top of my head. 18 times 18, you can just multiply here. 4, 6, 1, 4, 8, 1, right, and you get 4, 2, 324. So you get 324 pi. So my total area is 324 pi. Are we done? Well, no, because now we need to find the area of the boxes. So the area of this box, again, it's a square. We're assuming they're all right angles, okay? So provided that it's given that they're squares. We have a 5 by 5. So the area of the square that is circled, the area of one square would be 25. So the area of all of the squares, right, we're going to times by 4 and get 100. So the probability of success, which again comes from here, they're asking for the probability of landing in a box, would be 100 over my total probability, which is 324 pi. So this is, again, probability of success over the, I should not have put that, not probability of success, put the area of success over total area. Okay? And that equals that. Now, on the test, you're going to need to simplify your answer. Alright, so each of these can be divided by 4, and we would end up with 25 over 81 pi. And that would be your final answer there. Okay? That would be your final answer. Now, we don't put any units here because we're not talking about area specifically. We're talking about probability, right? So it's just a ratio. There's no units. We're not changing it to percent. We're not saying it's square inches or square meters, because if this is square inches and this is square inches, then those cancel each other out, right? So that we're not dealing with a unit, so that would be your final answer. Okay? There's two more examples. We should be able to fit this on one part here. So this is example 3, I believe. Now, what if I said the probability of landing outside the triangle? Okay, so outside the triangle. So that means, I'm going to highlight it real quick, landing anywhere on the outer parts here. So in the circle, but out of the triangle. Okay, so first of all, we're going to find the total area, right? We need to find the denominator first. I think it's the easiest. We're assuming this is going through the center here. So my radius, if my diameter is 12, my radius is 6, which means the area of the circle is 36 pi, right? Just pi r squared, so it's 36 pi. Well, what's the area of that triangle? First of all, what type of triangle is it? We have 90 here, two congruent angles here, right? Two congruent angles, which means it's 45, 45, 90. The hypotenuse is 12, and to get from the hypotenuse to the leg length, you divide by rad 2, and if you simplify that out, you get the leg is 6 rad 2 meters, which means this leg is also 6 rad 2 meters, right? So the area of this triangle is base times height, which are these two legs, so 6 rad 2 times 6 rad 2, and then it's half of that. Okay, so we end up with, my numerator is 36 times 2, which is 72, over 2, which is 36. So landing outside the triangle, well, I can do this in a couple ways. You can either say, well, the probability of landing inside the triangle is 36 over 36 pi, right? This is the triangle over the circle, right? Triangle over the circle, which simplifies the 36. 36 is canceled, and you just get 1 over pi, right? Well, then, what's the area of landing outside of the triangle? Well, it would just be 1 minus 1 over pi. And you could leave it like this if you want. If the options are only like, to leave it, or their common denominator, you would change this to pi over pi minus 1 over pi to get a common denominator, leaving me with pi minus 1 all over pi. Right, so this could also be your answer. These are interchangeable. They're the same thing. Okay, it's a weird answer, but it's an answer nonetheless. Alright, last one. So we're looking at the target symbol here, and what if I said, what's the probability of landing in the red? So if I'm like shooting an arrow or something, what's the probability of landing in the red? In fact, here's what I'm going to have you do. I'm going to see if you can do this, because we're about to run out of time on this part, and I really don't want to make an entire new part just for this video. But I'll give you a quick hint, and then you can try this on your own. So first of all, again, remember it's the area of the red. The area of the red over the total area, right? So here's the tip, and I'll let you do this on your own. The radius of this circle is 2. The radius of this circle is 2 plus 2, which is 4. The radius of this circle is 2 plus 2 plus 2, which is 6. Right, so the total area should be 36 pi, and then you're just finding the area of the red parts by doing the big circle minus the middle circle, because we want to take that out, but then you need to add the little circle again. Okay, and we'll talk more about that in class. But that's all we have time for today. This should set you up for the lesson. Try some problems in your book if you need to. Other than that, have a fantastic weekend. Bye, guys.